Welcome back. So in our previous video we started doing exercises on Developpement, and this is another exercise, and here we are asked to do almost the same thing as the first exercise. So in this case we are given this function 2, that's 1 plus x plus 2x squared plus x raised to the power of 3 plus x raised to the power of 5 sinus 1 over x, and we're asked to calculate the développement limité. So whenever I write DL, it's développement limité. So I asked to calculate the développement limité au voisinage de 0 à l'ordre n equal to 3, n equal to 4, and n equal to 5. So below I did another petit rappel on what the DL of a function is. We already said DL of a function is when we have this. That means we have the polynomial part. Like I said, on the card above you'll see a link that will lead you to the video on Introduction to Developpement Limité, where I already explained the definition of Developpement Limité. So this is the polynomial part, and we said this is the rest. And at each time you have to verify the limit. So when you verify the limit, you can now know if that function is also, if the function of that epsilon of x part, if it turn over 0. So we're going to start for when n is equal to 3. Same principle. So in this case too, you see that if n is equal to 3, so I'll just take this out so have space. Alright, cool. So we're going for when n is equal to 3. Now if n is equal to 3, it means we are going to use this. So we are going to have a3 x3. And if you notice, x raised to the power of 3, we have it here as well. And so that means our a3 is 1. So that means we are taking everything from here to be our polynomial part, just like we did in our previous video. So our f of x will be equal to 1 plus x plus 2x squared plus x raised to the power of 3. This is a polynomial part. It has been verified. So the next part is the rest. And we say when we are calculating the rest, we have to calculate x raised to the power of n epsilon of x. So our n is 3, so we're having x raised to the power of 3 epsilon of x. And whatever is left, we say whatever is left after bringing out the polynomial part is our rest. But in this case, we're having x raised to the power of 3. And here we're having x raised to the power of 5. So in order to get our epsilon of x, we have to factor out x raised to the power of 3 here. So it will be as it is here. So if I factor out x raised to the power of 3 from x raised to the power of 5, we'll be left with x raised to the power of 2. I'll tell us why. So we'll take this out. Okay, so we're having x raised to the power of 5 sinus 1 over x, and we're having x raised to the power of 3 already. And so to get epsilon of x, we have to factor out x raised to the power of 3 from this function, and so we'll be left with x raised to the power of 2 sinus 1 over x. How we're able to factor this out? This has tools in mathematics that says if you have x raised to the power of a times x raised to the power of b, it's the same thing as saying x raised to the power of a plus b. So if a here is 3 and b here is 2, so I have x raised to the power of 3 times x raised to the power of 2. It means x raised to the power of 3 plus 2, which will give me x raised to the power of 5. So that's how we have this right here. So this now becomes our epsilon, of x. Now finally, okay, so I'll clean this so we can write this nicely. So for n equal to 3, we have x raised to the power of 3. That's, we are still dealing with our rest, x raised to the power of 2 sinus 1 over x. And we say this is our epsilon of x. Now is the limit when x converges 0 of epsilon of x equal to 0. So we are going to calculate the limit of this function right here. So to calculate the limit of the function, we have the limit when x converges 0 of epsilon of x will be equal to the limit when x converges 0 of x squared sinus 1 over x. And this is equal to 0. I'll tell us why. Why it is equal to 0 is that there is a theorem that states that a function that is bounded, in French we say a function that is bounding, a function that is bounded or bounding multiplied by a function that approaches 0, the limit automatically becomes 0. So sinus 1 over x, I'll give us, okay, I'll do it right here. So there's a video on this particular topic, like bounded functions. You can find them, you find them where there are operations of suites when dealing with suites. So I'll put a card and a description that will lead you to the video to explain to you what a bounded function is all about. It basically talks about a function that is bounded above and below. That's a function that is majore and minore. So sinus 1 over x is a function that is bounded. That means it's between 1 and negative 1. So this is the same thing as saying sinus 1 over x in absolute value is 1. I can see that. Okay. So since sinus 1 over x is bounded, the theorem states that a function that is bounded multiplied by a function that converges 0 or approaches 0. Now we are asked to calculate the limit when x converges 0 of x raised to the power of 2. So that means we are replacing x to be 0, and so we're having 0. So this converges 0 multiplied by a function that is bounded, the limit will give you 0. So I'll just give us another example of a limit that can be calculated like this so we can get it clear. So it will be clear. So if I have, for example, we ask to calculate the limit when x converges 0 of, okay, I think my battery is low. Wow. Okay, of x squared cosinus x. It's also going to give you 0 because cosinus x is also bounded with negative 1 and positive 1. Same with sinus x. So whenever you see something like this, the limit automatically gives you 0 because of that theorem. So it's advisable if you actually state the theorem and say why the limit is equal to 0, because you're not calculating anything, so you have to explain why. So the reason is because it's a theorem that states that a function that converges 0 multiplied by a function that is bounded above below, so a function that is bounding, a function that is just bounded, the limit will always give you 0 as long as x converges 0, as long as x approaches 0. So I'll see you in the next video because I think the battery is low. So thank you for watching. Don't forget to subscribe and share. See you in the next video.